Hello, it's Keith here, and this is lesson 4 of the so-called Suck Hunt series of my Z80 programming tutorials, in which we look at my little game here, Suck Hunt. We're going to discuss some of the modules that make up the multi-platform code. We're going to be looking at the lifebar code and some of the graphics routines today, so we'll learn a little bit more about how this game works under the hood. But just in case you're not familiar with it, let's just have a quick play if I can remember the controls, which I possibly can't. So here's the game. Now, what we're going to be looking at is the lifebar, which you can see down here. So this is a 256 pixel wide screen, slightly wider on the 320 ones. There's some brackets at either side. The lifebar has the same number of units, it's just padded a bit on each side. And when the bats hurt us, you can see the lifebar goes down when they get to the foreground here. Very easy level here, you can see it's going down here. We're going to see the code that does that today. Now the sprites are XOR sprites, and this means that when we draw a sprite to the same position twice, the second time we'll remove the first one. So you're going to see that in the code a little bit. Now, before we continue discussing that, I want to point out, in case you don't know, I have written a book, and it's a book on multi-platform assembly programming, and it does cover Z80 along with 6502, 68000, 8086 and ARM. So if you're interested, it's designed at beginners. It's available on Amazon now. It's called Learn Multi-Platform Assembly with Chibi Akamas, and there's a link in the description below. So please take a look at that. Anyway, we're going to be looking at the game code today, and I suppose I should point out as well, this game is free and open source. So if you want to play the game or get the source code, go to the website and you can get both. And as I always say, you're welcome to do whatever you want with the source code. You know, you can swap a few of the sprites around and make it your own game, and if you want to sell that resulting game, doesn't bother me, because I can assure you I can't sell it myself. So you're obviously better at marketing than I am if you manage to do so, so good luck to you. Anyway, we're going to be going over the code, and we're going to be learning a little bit how it works. So we're going to start by looking at some of the lifebar code here, and we've got this routine called decrease life, and what this does is, it's when the player has been injured, we're going to remove one of those blocks and update the player's life accordingly. So what we're doing here is we are taking the count of the life units remaining here, and then we're working out a horizontal position from that, and we're adding 3. This is logical units. I say that because some of the screens are 256 pixel wide and some are 320 wide, but the logical units are the same on each. So the life bar is shown at basically position 3 horizontally on both systems, which may be the far left on the 256 pixel screens or slightly indented on the 320 ones, and the reason for that is, if our coordinates work the same on all systems, then there's less to change. So you know, some of the systems might not actually draw a few of the blocks, but by using the same coordinates we can deal with both. What we do have to deal with is the bottom of the screen is different, though. It's slightly shorter on some of the systems, so the Y position is different. And of course we're working in 3D, so we have a Z position, and that's the stereoscopic depth. We can have the life bar sticking out, or we could have it sticking in. It's actually sticking out, but that's what we're doing there. We've got our locate routine there, which moves the internal variables to update for the next draw of a block, and we're using the print character routines to draw the blocks of the life bar to the screen. They're actually part of the font. It's an 8x8 pixel font, which is fine, and there were a few characters left for our life bar, so that's what we've done here. The Sega Master System has a draw sprite routine here. All of the other systems are XOR, so drawing a character twice will remove it, but the Sega Master System doesn't use XOR, so that's why we're doing that. It couldn't use it because it's using a tile map. Now, what we're doing here first is we're going to take away one of the player's life blocks. So we need to remove a full life block and draw in an empty one. And the way we remove a sprite, as I say, because it's XOR, is we draw what was there before. So we're drawing a full life block, which is character 128 here. And then we are drawing in its place an empty life block, which is character 127. So that's what we're doing. That's why we're drawing to the same position twice here. We're using locate X, Y, Z to set the X and Y and Z positions here, and then just locate the second time, because we don't need to set the Z position again because it will be unchanged. The horizontal position would automatically update after each draw, you see, so we do have to change that. Now, so here we are drawing the block of life, but then we're going to just check if the player's actually run out of life. So we're removing 1 from the life count here. And if the life blocks have reached 0, then the player is dead. So we're going to jump to the game over routine. Otherwise, the player can still continue playing. So we're updating their life, and we're making the sound of them being sucked by a vampire back there. Now this is the decrease life function, but we do have a function to show the entire life bar, and this is used when the game starts or when the screen has to be completely redrawn. For example, if the player has changed the stereoscopic depth, we need to redraw the entire screen. So that's what this does here. Now, here we are setting the Z position here to -10, and then we're setting the X and Y position. Now on the 320 pixel wide screens, we draw some square brackets to the left and the right of the life bar. So the life bar is the same size, 32 tiles on each system, but we're just padding it out to fill the screen on the larger systems there. We've got a function here called show life again, and this will basically repeatedly show a character to the screen until B reaches 0. So we use this various times in our life bar routine. So first of all, we're using it to draw 4 square left brackets on the left hand side of the 320 pixel screens. Then we're showing the life bar, and then finally we are going to show the empty blocks to the screen using this show empty life function, and then we are going to show the right brackets, and then we're going to return. Now, the empty life routine shows character block 127, which, as we discussed before, is our empty life block. Our regular life bar routine, if there's any blocks to show, will show the block 128 here. And either way, we're using this routine here to show the actual blocks to the screen. Okay, so that's the life bar. Now, the other thing we've got on the screen is the bullets. Now the bullets, if we just wait for this to start up here. Now the bullets are shown at the bottom of the screen in the center here. You can see we've got the text bullet message here. Then we've got a count of the number of bullets loaded into the gun, and then a count of the remaining bullets. Now this default 6.66 shooter has infinite ammo, so we've always got 255, but it can only load 6 bullets at a time. So we're going to now draw that to the screen. That's what we're doing here. So we're setting the Z position and the X and Y position here, and we're locating for the first line, and then we're showing the text string, which is bullets colon here, showing that to the screen. We're then moving down one line, doing another locate, and then we're getting the address of the ammo state for the current gun. We're loading the current number of loaded bullets here. We're showing that to the screen as a decimal number. We're then showing a slash, and then we're loading the remaining bullets, which is known as the magazine in this, and we are doing that. And of course, we're using IX each time as the offset to the data relating to the currently selected gun, and that's being filled in by the get ammo command here. So this is showing that bullet information to the screen. Now the game, of course, has a cursor which is mouse controlled, and the cursor moves much faster than everything else in the game, because otherwise it would be rather clunky. So we've got a routine that handles that, and also the resolution of the cursor on many systems is higher resolution than the internal logic. The game's logical coordinates work in pairs of pixels, but some of the systems work at pixel resolution depending on the system, and also some of them work in fractions of a pixel as well. So we might want to, for example, move, depending on our mouse, we might want to move, say, half a unit across the screen for every 1 unit down the screen. And so to do this, we're using 16-bit numbers, and it's the top byte of those 16-bit numbers that are used to draw the graphics to the screen, the coordinates for drawing, and the low byte is basically a fraction that we can use for more precise movement, just depending on our mouse. So that's what we're doing. Now what we're doing here is we're loading the old position of the cursor and the new position of the cursor, and we're subtracting the two, and if the result is 0, then the cursor hasn't moved and we just return. If the cursor has moved, then we're going to have to remove it and redraw it. And once again, we're using XOR sprites, so we're just drawing to remove the old cursor. We're just using the old position to remove it and the new position to draw it again. Okay, so here's our functions to do that. We've got our remove old cursor function here. So we're loading in the old position of the cursor here into B and C, which are the coordinates. And then we're using our show crosshair function, which is a platform specific function. This uses hardware sprites on some systems like the Master System. It's in software at high resolution on some systems like the MSX. It really depends on the system, so it's platform specific. Okay, and then we've got our show cursor routine to show the new cursor to the screen. So we're now updating the old position to the current position. That means that next time this function here runs, nothing will have changed. And then we are loading in the new position of our cursor, and we're showing the cursor to the screen again. Now you will notice, however, that this function may have already been defined. I think that's a Master System. I had to use a totally different function because it didn't make sense to use these coordinates for that system because of the light gun. I had to make the routine that did the light gun very fast, and the code that did it basically was doing all of this already. So it didn't make sense to have this function on that system. So we do have the potential to disable that just here. Okay. So that's the cursor. The next thing and the last thing we're going to look at this time is the Repaint screen function. Now, when the player changes the stereoscopic depth, we need to clear the screen and then redraw everything on the screen. And also at the start of the game, we'll need to draw everything as well. So we've got a function to completely redraw the entire screen in one go here. So this is made up of various sections. We've got the redrawing of all the sprites, the showing of the cursor, the showing of the bullets, that's the bullets we just saw, the count, the showing of the life bar, showing of the name of the gun, and the showing of the score. That's basically all of the categories of objects that we need to draw to the screen to completely redraw the screen. Now, what we're going to look at here is the repainting of the sprites function. Now, the sprites in this game use a 16-byte block of data for each object, and the data in that object can be used to do everything about the sprite. So it defines where in memory or where in the patterns the sprite data is, the current position of the sprite, the movement of the sprite, and things as well. So what we're doing here is we're loading IY with the first sprite we want to show, and then we're using one of two functions to show that sprite to the screen. Either draw sprite from IY or draw sprites from IY, because some of these are a single sprite, like there's just one power-up sprite, the gun is just one sprite, the moon is just one sprite, and also surprisingly the mountains are just one sprite. We'll discuss that in a moment. But things like the clouds, the grass, the rocks, and the enemies, there's lots of those, so we need to do an array, and we load the count into B, and we'll see these functions in a future lesson. So we're not going to discuss those today, but what we're going to discuss is a little trick I did here with regards to the mountain. Now, the game itself, although it has lots of mountains on the screen, they never actually move, so we didn't need to really have these all defined as separate sprites. So we've done a bit of a trick. What we've done is we use a single sprite object to save memory, and we just move it each time. So here we are basically loading in the count, adding 0C, which is the first position of the mountain on the screen, and then we're drawing it to the screen repeatedly, decreasing our loop counter each time so that that one sprite is being used to show all of the mountain objects to the screen. That saves a little bit of memory, and it does a perfectly decent job. So this routine is used a couple of times in the game, as I say, primarily at the start of the game and also when the stereoscopic options are changed. Anyway, there we go. So that's all we're going to be covering today. As I've already said, if you like what you saw, please go to the website and you download the source code and download the game and maybe have a go with it. Maybe you'll find it a bit amusing. I had some fun. I like my stereoscopics, so I enjoyed making a stereoscopic game. And as I said before, if you want to support my content or you want to learn assembly and you like the old printed material, you can get the book, my book, Learn Multiplatform Assembly Programming with Chibi Akumas, as a printed copy, but you can also get it as a Kindle book if that's what you want as well. So give either of those a go depending on your preference. Anyway, I hope you found this interesting. Thanks for watching today, and goodbye.